Everything good?
No, listen to this. Someone hacked my B-Dubs account and redeemed all my reward points to get free food. I am having the worst day. I tried to email B-Dubs like, are you going to give me my rewards points back?
I'm so sorry.
How does that even happen?
Well, at least they didn't like charge your credit card or something.
I know. Well, that's why I called Tony. I'm like, it said 0, but I'm like, still check your card just in case. But
Yeah.
they took all. I've been saving those. My door shut?
Yes, please. Morning, everyone.
Good morning.
How is everyone today?
I couldn't hit the button. I'm tired.
Tired. You're so tired you can't even hit the button.
Yeah, I can't. I tried.
But we only have 3 days this week, so you got to be excited about that. Rachel, were you trying to say something? I saw your mic go off, but I could never hear you.
Yeah, I guess I was trying to answer the question. I think my mic cut out though.
Gotcha. Now I can hear you. Whew. I'm so pumped about only 3 days this week. And then we get to come back. Oh, it's going to be a good week. I can tell. I'm going to wait another minute here to see if we have anybody else join us. Anybody do anything exciting over the long weekend?
Nope.
No. We were supposed to go, I was going to take my kids tubing over the weekend, and my sister was making arrangements, a place where they make their own snow type thing. And but my one daughter, my middle child, broke her ankle like a week ago, 2 weeks ago. So that went out the window. So we didn't do much. Grocery shopping, that kind of exciting stuff. All right, we're going to go ahead and get started. Some people might be jumping in. That's okay. I'm going to share my screen with you. All right, so on, let's see, where were we? Thursday and Friday, we were talking about parallelograms. Okay, so today we're going to talk about rectangles. Okay, and a rectangle is a parallelogram. It's just a very special one. Okay, so the next couple days here, we're going to be talking about special parallelograms. Okay, so today we're talking about rectangles. So I'm going to talk about some properties of parallelograms and rectangles. So keep in mind, because a rectangle is a parallelogram, it's going to have all those parallelogram properties. Opposite sides being congruent, opposite angles being congruent, the diagonals bisect each other. Okay, that's still all going to hold. Here's what's extra special about the rectangle. So first of all, they have all right angles. So all 4 angles are right angles. So they all measure 90 degrees. Okay. The other thing that's extra special is that diagonals are congruent to each other. Okay, so that means like if this diagonal here is 20, then the other diagonal is also 20. Well, keep in mind they bisect each other as well. So for instance, if this was 10, then this is 10, this is 10, this is 10. Okay, so something to keep in mind, because those diagonals are congruent, all of these triangles that are in here are isosceles triangles. So remember, that means our base angles are congruent then. Okay, so that's just something to kind of keep in the back of your head, okay? So I have lots of examples to go over with you today. So let's start there, and if you have questions, make sure you jump in. So I started us off easy here. So all of these figures are gonna be rectangles, and I did put that in the instructions, that way I didn't have to mark everything up on the figure to make it more crowded. But just like parallelograms, opposite sides are gonna be congruent. So if this side is 25, then X is also going to be 25. If this side is 15, then this side is also going to be 15. Okay, so those are nice and easy. Something I want to remind you of is we do have parallel lines, right? So let's start up here in this corner. Keep in mind, this does measure 90 degrees. So if I want to find the value of X, I can take 90 and subtract 32, and I would have 58 degrees. So I know X is 58 degrees. Okay, now because I have parallel lines, remember then this is my transversal, and we talked about how we have that Z, so we create alternate interior angles. So 32 and Y are alternate interior angles, and they're going to be congruent. Okay, so these 2 angles here are going to be congruent, so therefore Y has to equal 32 degrees. All right, next one. Okay, so I brought this in for a couple of reasons. I wanted to remind you, first of all, keep in mind, because it's a rectangle and the diagonals bisect each other, then these 2 parts here are going to have to be congruent. Okay, so those 2 parts are going to have to be congruent. Hold on one second, guys. I gotta figure out who I just let in. Michael. Okay.
I just came in.
Okay, thanks. Sorry, I was couldn't remember. I just hit accept.
That's all good.
I just needed to write it down for attendance, that's all. All right. Okay, so keep in mind, because the diagonals bisect each other, we end up with this isosceles triangle. So we know that the base angles here are going to be congruent. So therefore, X has to be 55. Okay, now think about, we have a triangle, right? So if I take 180 and I subtract the 2 angles that I know, that's going to leave me with 70 degrees for Y. Okay, now we have one more here. We have Z. So these 2 make a linear pair, right? So we have to take 180 and subtract 70, and I get 110. So Z here has to be 110 degrees. So remember, here's the other thing that we could have shortcutted it a little bit. Keep in mind, remember how we talked about those triangles with the exterior angle? That's what we have here. This was 55 and this was 55. And I needed to know this exterior angle Z. Remember how the sum of the remote angles equals my exterior? So I could have gotten, I needed 70 anyway, so it's just as easy to use a linear pair. But keep in mind, this exterior angle does equal the sum of the remotes. All right, so there's some basic properties there with just constants, with just numbers. So I'm going to show you a couple here with some algebra, kind of get us going in that direction. So, but the same rules apply. We know opposite sides have to be congruent. If they're congruent, then we can set them equal to each other. So I have 7x minus 12 equals 4x plus 18. So I can subtract 4x from both sides. So I have 3x minus 12 equals 18. Add 12 to both sides. I have 3x equals 30. Divide by 3, I have x equals 10. Okay, so we have to keep those properties in mind. If I know they're equal to each other, I got to set the expressions equal to each other. All right, on this next one here, we know every angle has to measure 90 degrees, which means this expression then has to equal 90 degrees. Okay, so I can subtract 12 from both sides. So I have 13x equals, let's see, 78. So that's got to be 6. So divide by 13. So x would equal 6. Okay, so keep in mind the algebra is really about thinking about those properties that we started with. Let's do another one here. All right, so this is referring to the parts of the diagonals. So remember, all parts of those are congruent, which means those two expressions have to be equal to each other. So 8x minus 18 has to equal 4x plus 58. So I can subtract 4x from both sides. Then I can add 18 to both sides. So we have 4x equals, let's see, 76. So x is going to equal, let's see, that'd be 19. X would equal 19 if I divide by 4. All right, so let's talk about the setup of the last two, because I don't want to lose you. I'm afraid that like some of you are drifting off already. Okay, so keep in mind these are alternate interior angles, right? So those are going to be congruent because of my parallel lines, which means these two expressions have to be equal to each other. Okay. Well, I guess we can solve them. We only have 2 left. So I'll add 3x to both sides. So I have 8x plus 3 equals 27. Now I need to subtract 3 from both sides. So 8x equals 24. Divided by 8, we get x equals 3. So a lot of times you're just trying to figure out, are they congruent? Do they equal 90 degrees? Are they equal 180? That's what you got to kind of figure out here. Okay, last one. Last one. So these two angles, keep in mind, this is my isosceles triangle here, right? My isosceles triangle. Those are my congruent sides. So that means that these two angles have to be congruent, which means I'm going to set them equal to each other. So I have 6x plus 13 has to equal 9x minus 14. So I can subtract 6x from both sides. I have 3x minus 14. Add 14 to both sides. So I have 3x equals 27. Divide by 3, I have x equals 9. All right, so that was a lot of different examples, but keep in mind, think about those properties. Opposite sides are congruent, opposite angles are going to be congruent, but they're all right angles. Keep in mind about the alternate interior angles, the isosceles triangles for us, right? And the fact that the diagonals are congruent and they bisect each other. So you have 4 congruent parts here. All right, questions on any of that? I feel like that was really fast. Maybe not in your eyes, but for me, it seemed like it was fast. All right, so your homework today looks like this. So when you open it, I put view, if you want to view this whole thing, it's at 50%, but you might have to zoom in just a little bit to see the problems a little more clearly. But all of these are rectangles. Okay, so everything is a rectangle. Again, I didn't mark it all up because I didn't want to overload the picture. So the way this is going to work, I'm going to zoom out here. It looks better on your Chromebook because I made sure that it fit on your screen, but this is like a color by number. So if you get number 1 right, it'll fill in the 1s. Then do number 2, it'll fill in the 2s. You should do this in order though. So I'm telling you right now, if you fill in number 5, it's not going to fill in anything until you have 1 through 5 correct. So I really would do this in order. Okay, so start with number 1, get number 1 correct, and it'll fill in the 1s. Then do number 2, get it correct, it'll fill in the 2s, okay? So this will be fully colored by the time you get down to number 10. Any questions at this point? All right, so go ahead and get started, and if you need help, let me know.
Miss Owenga,
Yes.
so I did my missing work, and
You did missing work from the first 9 weeks. Did you see my, did
I
you see
did.
my email to you?
no,
Every assignment you turned in was from the first 9 weeks.
okay,
So you're gonna want to go back, like work on. Did you do that animation thing? Trying to see if you did. If you finished your transformation animation. No, go do that. That's 50 points. It's huge. So work on your transformation animation. Zoe, did you hear me?
what? No, I didn't.
So all those assignments you did were from the first 9 weeks. Okay, so you really need to focus on the second 9 weeks because we can't change the first 9 weeks grade at this point.
I thought it was the second 9 weeks.
No, sorry, hun. So what I would do if I were you, you didn't do that transformation animation project. So I would go through, I would do that one. It's 50 points.
Okay,
So I would start with that one.
Miss Canterbury,
all right.
Okay.
tomorrow I'm not
Okay.
gonna be here because at 9 I have a